how do I identify the inverse of a function? Y equals 3/5 x minus 1/2. First thing I'm going to do is I'm going to come up here and put in this function. It's important to see that here's the function, x goes on the outside, and then I'm subtracting 1/2. Now I'm going to look for values. 0 goes with negative 0.5. 1 goes with 0.1. 2 goes with 0.7. And it goes in this direction for this function. But I know the inverse of this function needs to reverse it. So I'm going to come up to stat and press enter and plug in this first. And then the corresponding y's. Go stat, go to calculate, go down to number 4, and press enter all the way through. Okay, so yours will be much nicer, but what you could write here then is this will be the function. So 1.6 repeating x plus 0.83 repeating. Okay, let's try one more. The first thing I'm going to do is make my 2 circles, and let's figure out some things here. So I'm going to restart the calculator by clearing the RAM. Remember, when I plug this in, the fraction goes in parentheses, the x is on the outside. Now second table, let's retrieve some points. 0 goes with 3, 1 goes with 2.6, and 2 goes with 2.2. Go to stat, edit, now we need to reverse it. So I'm going to start with the 3, the 2.6, and the 2.2. Go into stat, calculate, go down to linear regression, press enter all the way through. So the inverse of this is negative 2.5x plus 7.5. Right, let's look at the next one. If I gave you a table, and it said 0, 1, and 2, and they went with 5, 7, and 9. 5, 7, and 9. And I said this is what we're going to call function f of x. So let's make this an f of x. Make your x and y. And now I asked for the inverse of this function. What would we do? We take these values and take these values. And now in words, you have to describe how the inputs of this function become the outputs of the inverse. And the outputs of this function become the inputs of the inverse. In this problem, we are asked to prove that these two are in fact inverses of one another using the composition of functions. So I'm going to start by writing this down. Oop, with a big parenthesis. I do not put the x in here. The x is eliminated. Now in this spot, I'm going to take this and put this in place. Okay, let's multiply. 15, 15, bring down the x. 3 times 5 is 15. 5 times 6 is 30. 15 over 15 is 1. If you put this onto your calculator, you'll end up with a 0.5. Well, 0.5 is the same as 1/2. I need to see all of your steps just like this to get credit. These are called additive inverses, the same number with different signs. And now we're good. We've got to do the same thing, but we're going to reverse it. So starting with the first one, I start with the second equation. Don't put the x in there. So this is the part, but I take out the x and leave a blank spot. Now I'm going to put the first equation into this one. 5 times 3, 3 times 5. 5 times 1, 3 times 2. 15 divided by 15 is 1. These are additive inverses. I showed all my steps. And this is our goal, to prove that we get y equals 1x every time. Not y equals negative 1x, not y equals 1x plus 5, but exactly like this. Let's try the same thing again with two different problems. Let's prove these two are inverses of one another using composition of functions. Write down the first equation, leave a big space where you see an x. This is going to be put into this position. Okay, let's do the work. A negative times a negative is a positive. 2 times 5, 5 times 2. Bring down the x. 2 times 15, 5 times 2. Now there's a negative here. Notice a negative times a positive is a negative. 10 divided by 10 is 1. 30 divided by 10 is 3. We have additive inverses. I'm showing all of my work. Now the next one, I'm going to write down this equation. I'm going to start this time with the second equation instead of starting with the first. And replace the second equation into the spot. Okay, a negative times a negative is a positive. 5 times 2 is 10. 2 times 5 is 10. A negative times a positive is a negative. Now this is confusing. I only multiply the 5 times the 3. So negative 5 times 3 is negative 15. And 2 times 1 is a hidden 1 is 2. 10 divided by 10 is 1. These are additive inverses. They cancel out. And I just proved that these are in fact inverses of one another using composition of functions. Lastly, if I asked you to accurately graph this line, what are you going to do? Well, this is the line, but I want you to accurately graph, the inverse. So first I'm going to write this down. This is the ordered pair 1, 0. This is the ordered pair 0, 2. And this is the ordered pair negative 1, 1, 2, 3, 4. So this belongs to this function. We'll call that f of x. Now the inverse, I'm just going to swap them. 0, 1, 0, 1, 2, 0, and 4, negative 1. And now I have to graph it. So 0, 1 is right here. 2, 0 is right here. And 4, negative 1 is right here. And this is the inverse.